This is the Geometry Chapter 9 review, actually the last two sections of Chapter 9 review. I'm going to answer these 20 questions as quickly as I can so the video doesn't last forever. You can, of course, pause the video at any time to see what I'm doing. The definitions for the ratios of the sine, cosine, and tangent are as such. Question number 2, find the value of the variables. For the first one, looking at the 52-degree angle, this is the opposite and this is the hypotenuse. Because of that, I've got the sine, and so I'm going to say that the sine of 52 degrees is equal to x over 15. So x is equal to 15 times the sine of 52 degrees, and that would be approximately 11.820. For the second one, I'm looking at, compared to x, this is the adjacent and this is the hypotenuse. And so in this particular case, I'm looking at the cosine. The cosine of 37 degrees is equal to x over 14. So x is equal to 14 times the cosine of 37, which is approximately 11.181. And finally, the last one, I am looking at, compared to 24 degrees, this is the opposite and this is the adjacent. The tangent uses the opposite of the adjacent, so the tangent of 24 is equal to 8 over x. Remember, I can switch these two, and so x is equal to 8 over the tangent of 24, which is approximately 17.968. Number 3, remember I'm looking for angles this time, so I want the inverse. Looking at n, the tangent of n is equal to 11 over 18. So n is going to be equal to the tangent inverse of 11 over 18. If you take that rounded to the nearest degree, you'll find out that n is equal to 31. You would also find that p is going to be equal to the tangent inverse of 18 over 11. That should give me 90 minus 31, which is 59 degrees. On the second one, compared to u, this is the opposite and this is the hypotenuse. So this time I'm going to say the sine of u is 7/23. Tells me u is equal to the sine inverse of 7/23, which is going to be approximately equal to 18. Well, if u is 18, then s must be approximately equal to 72. Did we miss one? Number 4, draw an angle of elevation and depression. Oops, apparently I missed it. Let's try it again. Notice I've got horizontal lines. My angle of elevation goes up from a horizontal line. My angle of depression comes down from a horizontal line. There's my angle of elevation and depression. Now, number 5, Miguel looks from the crown of the Statue of Liberty. So over here is my Statue of Liberty. Isn't she very pretty? And he is looking at a ship. Here is my ship. Going to be a little sail ship, I guess. And the Statue of Liberty is 250 feet above the ground. The ship that he sees coming into the harbor has an angle of depression of 18 degrees. Remember, that angle has to be horizontal. I didn't draw it very well to scale. This is 18 degrees. If the angle of depression is 18 degrees, the angle of elevation is also 18 degrees. I think I will just use this one. And I am trying to find the distance from the base of the statue to the ship, which is this distance here. In order to solve that, I'm going to say that the tangent of 18 degrees is equal to 250 over x. So x is equal to 250 over the tangent of 18, which is approximately equal to 769.421 feet. Number 6, I've got a kite. Here's my kite, and it is on a 100-foot of string at an angle of elevation of 22. So this is a 100-foot string, has an angle of elevation of 22 degrees. And the hand holding the string is 4 feet above the ground. So look, there's the hand. It is 4 feet above the ground. So the kite over here must also be 4 feet. If I can find this value, add 4 to it, that would give me the value of the height above the ground. So in this particular case, I'm looking at this angle. That's going to be the sine. So the sine of 22 is going to be equal to x over 100. So x is going to be 100 times the sine of 22. That's going to give me approximately 37.461. However, don't forget I've got to add the 4 from the hand, and so x plus 4 is approximately equal to 41.461. Number 7, got a tall building here. The tall building is 107 feet, and it's casting a shadow of 90 feet. And we want to know the angle of elevation to the sun. Well, the sun must be up here if it's making an angle. So in this particular case, I'm just trying to find this angle of elevation to the sun. Compared to x, I've got the opposite and the adjacent. The tangent of x is equal to 107 over 90. So x is equal to the inverse tangent of 107 over 90. And that is approximately equal to 50 degrees. Number 8, a 6-foot tall man, a little bit taller than me, is looking at the top of the tree. So here's my tree, and he's looking at it with an angle of elevation of 83 degrees. He's standing 12 feet from the base of the tree. This is a 6 feet. I guess his eyeballs are right here at the 6 feet mark, and he's up here looking at the top of this tree. And I want to know how tall is the tree. Here's my angle of elevation of 83. And so I'm going to find this value of x, add the 6 to it down here, and that will give me the height of the tree. In this case, I once again have the opposite and the adjacent, because if the bottom is 12, this is 12 also. So I've got the tangent of 83 is equal to x over 12. So x is equal to 12 times the tangent of 83, which is approximately equal to, wow, those are some strange looking approximate bars, 97.732. I've got to add 6 to that to get my total. So my total is going to be approximately equal to 103.732 feet. That's a pretty tall tree. Number 9, a bird is flying above a tree. So I've got a tree, and I got a bird flying above the tree, and I'm standing 30 feet away from the tree, and the angle of elevation to the top of the tree is 47 degrees, and the angle of elevation to the bird is 54 degrees. Let's try that again. The whole thing here is 54 degrees. What is the distance from the bird to the tree to the nearest 1,000? Here's my picture. Well, what I'm going to do, I'm going to actually use 2 right triangles. The first right triangle will give me the height of the tree. The second right triangle will give me the height of the bird. And if I subtract the height of the tree from the height of the bird, that will give me the total that I need. And so I guess I'll start with the height of the bird actually first. We got a tangent going on here again because I'm looking for this side over here, and I'm going to call the height of the bird y, and I'll call the height of the tree x. And so the height of the bird we're going to find by saying the tangent of 54. Let me keep it color coded here. The tangent of 54 is equal to y over 30. 30 times the tangent of 54 is approximately equal to 41.291. And then I've got the height of the tree. The tangent of 47 is equal to x over 30. So x is approximately equal to, if you do 30 times the tangent of 47, you'll get approximately 32.171. And if we do our subtraction, the height of the bird subtracting the height of the tree, we should get approximately 9.120 feet. The bird is about 9.120 feet higher than the tree, higher than the top of the tree. Number 10, define a vector. Ta-da! Number 11. Find the component of the vector with the initial point -2.5 and a terminal point 7.3. I'm going to show you both ways to do this since I haven't really done many of these in class. I'm at -2.5 here, and I'm at 7.3 here. And I want to look at the component form. The component form is going to be how far am I going right and left, and then how far am I going down. Well, going right and left, I go from -2 to 7, which is 9, and going from 5 to 3 down, that's -2. So the component form of my vector is 9, -2. Notice it's a vector, so I'm using the less than greater than signs. I also could write this as the component form of my vector is x2 minus x1, comma, y2 minus y1. Apparently I've done something here. There it is. I didn't have to do that again. And so I would have gotten, in this particular case, 7 minus -2, comma, 3 minus 5. And sure enough, that would once again have given me 9, -2. All right, let's do 30 degrees north of west. Well, this direction is west. I'm going north of west, so I'm going to go up here 30 degrees north of west. Then I want to go 75 degrees south of east. Here's east. I'm heading south of east 75 degrees. That is 75 degrees south of east. C is a little bit different. Here I'm going east first, and then I pop up 25 degrees north. So that's east 25 north. And finally, D, I start off going north, and then I cut out 46 degrees west. Was going north, then going west towards it. So let's try that again. This is 46 degrees here. Isn't that beautiful? Find the magnitude and direction for the vector -3, 7. The vector -3, 7 goes out 3 and down 7. The magnitude is just going to be the distance from here, the tail to the head. Well, this is 3 and this is 7. Let me put the 7 over here, make it look like a right triangle. 3 squared plus 7 squared is equal to the magnitude squared. 9 plus 49 is equal to the magnitude squared. 58 is equal to the magnitude squared. So the magnitude is equal to the square root of 58. Square root of 58 can't be simplified, so I am done. To find the direction, I have a couple different ways to do it. I could do it west of north. Let's see. Holy cow. This is at -3, so the idea is still the same. Let's fix this thing and do -3, 7, where I should have been, because otherwise my magnitude's not going to change. My direction would be pretty bad. So now I'm looking, if I look at this thing as being west of north, I'm going to look at this angle right here. Compared to this angle, this is 3, this is 7, and so I can say that the tangent of x is equal to the opposite over the adjacent. So x is equal to the tangent inverse of 3/7. The tangent inverse of 3/7 is going to be 23 degrees. So I'm going to call it 23 degrees west of north. Number 14. Let's find the vector's component form, magnitude, and direction. The trick here is, look, this is 10, right? So I've actually gone out to 70, and the component form is actually going to be 72. If that's the case, then my magnitude, I can find the magnitude by squaring this number, adding the two together, and taking the square root, right? It's just the Pythagorean theorem. That's approximately equal to 70.028. The direction is going to be the tangent inverse of 2 over 70, which is going to be approximately 2 degrees north of east. Or you could also call that east to north. Number 15, find the vector's component form, magnitude, and direction. Well, the magnitude for the left one is 65, and the magnitude for the right one is 900. The direction for A is going to be 50 degrees south of east, and the direction for the second one is going to be 48 degrees north of east. Those were pretty stinking easy. The trick is, what is the component form? And in order to find the component form for these, I'm actually going to have to do my trig functions again. For the left-hand side, or for A, I've got the cosine of 50. Cosine of 50 is going to be x over 65. And for the y direction, the sine of 50 is going to be equal to y over 65. And if you work those out, it's going to be about 41.781. That's 65 times the cosine of 50, and 49.793. That is going to be 65 times the sine of 50. Same thing over here for B. This time I'm going to draw this here. This is the x direction, this is the y direction. The cosine of 48 is going to be equal to x over 900. That's going to give me the x direction, which is about 602.218. And then to find the y direction, I'm going to do the sine of 48 is equal to y over 900. That's a y, not a 4. Y over 900. That would give me approximately equal 668.830. All right, number 16. I'm going to draw the resultant vector. If we do this correctly, it should look almost like a parallelogram. I'm going to let this be my first vector. The second vector goes left 4 and down 2. So from this vector, I'm going to go left 1, 2, 3, 4, and down 2. My resultant vector, therefore, looks like this. And it is -6, 2. Over here, I'm going to let this be my first vector. My second vector goes right 2 and down 3. So from here, if I go right 2, down 3, I end up at -1, 0. It's this vector right here. And finally, I'll let this be my first vector. The other vector goes right 1 and down 2. So here is my resultant vector. And this resultant vector is at -3, -5. Number 17. I want to know the boat's direction and the boat's actual speed. To find the boat's direction, I would say according to x, which is this angle right here, that the tangent of x is equal to 8 over 35. So in this particular case, x is equal to the tangent inverse. Because I'm trying to find the angle, I use the inverse function of 8 over 35, which is approximately equal to 13 degrees, and it looks to me like I'm going south of west, 13 south of west. How do I find the actual, let's see, the direction, how to find the actual speed? I'm going to use Pythagorean theorem. And so here's the speed in miles per hour. Let's call it c, because I've already said it was c. So c squared is equal to 35 squared plus 8 squared. C squared is equal to 1225 plus 64. C therefore must be equal to the square root of 1225 plus 64, 1289, and they wanted it in miles per hour. Let's see, so the nearest thousandth, C would be approximately equal to 35.903 miles per hour. 18. Tall building cast a shadow of 90. Oops, that's not it. Let's try that again. A twin-engine airplane encounters a speed of 300 miles an hour in still air. This airplane is heading directly south. Use your imagination. Pretend I drew that directly south at 300 miles an hour, and it encounters a 50-mile-an-hour wind blowing east. The resulting speed, therefore, is going to be found by the Pythagorean theorem. 300 squared plus 50 squared is equal to c squared, the speed squared. If we work that out, 300 squared plus 50 squared is 92,500. We'll take the square root of that, will be equal to c. C is approximately equal to 304.138 miles per hour. That's about how fast it is going. In what direction is it going? Well, if this is x, the tangent of x is equal to 50 over 300. So x is equal to the inverse tangent of 50 over 300, which is 1/6. We'll just go ahead and leave it as the inverse tangent of 50 over 300, which is approximately equal to 9 degrees. And it looks like we are going 9 degrees east of south. Number 19, Sam is looking at a map of her town. She sees that the grocery store is 8 miles. So let's go ahead and draw this thing. 8 miles, 60 degrees north, 60 degrees east. Okay, so this is 60 degrees, north 60 degrees east, and this is an 8 from her house. The park is exactly 3 miles due north of the grocery store. So if this is the grocery store and this is the park, how far is Sam's house from the park? And so we're actually trying to find the distance from here to here. Okay, let's see if we can figure out a right triangle. I think in order to find a right triangle, I'm going to go down here. Okay, and let's see if I can find some things out. If this is 8, if this line here is 8, and this is 60 degrees, this angle here is a 30-degree angle. So that's the hypotenuse of a 30, 60, 90 triangle. This must therefore be 4. And this, being the longer leg, must be that number times the square root of 3. I've got a 4 root 3, 8 triangle here in blue. And I also know that the distance from here to here is 3, so the leg of my big triangle is going to be 7, and this is going to be 4 root 3, and I want to find the distance here. I've got another right triangle, so I can say 4 root 3 squared plus 7 squared is equal to c squared. Well, 4 root 3 squared, remember I do 4 times 4 times 3, 16 times 3 is 48. And of course 7 squared is 49, is equal to c squared. So c squared is equal to 97. C is equal to the square root of 97, which is approximately 9.849 miles. A little bit less than 10 miles from her house to the grocery store. Person leaves in a canoe, leaves shore at a bearing of north 47 degrees west. So I went north, then I went out 47 degrees west. There it is, and paddles at a constant speed of 2.5 miles per hour. There's a 2 mile per hour current moving it due west. And what is the canoe's actual speed round to the nearest thousandth?